Probability questions towards the end of the exam paper are always quite challenging. There's no set method to do them, but I think trying to do a tree diagram often helps. But remember with this, you don't have to complete the entire tree diagram. You don't have to draw the whole thing. You'll see what I mean when I start answering the question here. So we've got a bag with some beads, they're red and blue. You take 2 out. So the implication of that is you remove 1, and then you have 1 less in the bag before you remove the next one. So that nothing's returned back in. That's a key part of the question. We have a choice of red and blue, and then we can pick another one, which is either going to be red or it's going to be blue. So my tree diagram would still look something like this. Now, I'm not going to fill it in just yet. Looking at the question, it says, what is the probability? Oh, it says the probability that 2 will be the same color. So that's red, red, and blue, blue. So I'm dealing with 2 of these strands here, and I want to work out the value of n. So if I can form an equation involving n for red, red plus blue, blue equal 9 over 17, that equation will have one unknown, which is n, and then I'll be able to solve my question. So I only want to work out the roots that go this way and this way. So I'm not going to worry about the 2 in the middle now. Now, I have n beads and 6 of them are red. So the probability of picking a red out first time will be 6 out of the n beads that I have. Once I've taken a red out, I have 1 less bead in the bag and 1 less red in the bag. So the number of reds I have now is 5, and the number of beads left in the bag is n minus 1, 1 less than n. So the probability of putting red followed by red, you know how it works with tree diagrams. You multiply when you're going across here, so it's this multiplied by this. So for red, red, it is going to be 6 over n multiplied by 5 over n minus 1. And that equals 30 over n minus 1. That's the probability of picking red, red. Now let's do blue, blue. At the beginning, there are still n beads in the bag. And if I pick a blue one, well, how many blues are there? Well, there are n beads and 6 of them are red, which means the rest of them are blue. So it's n minus 6 blue beads in the bag. Now, when I take a second one out, there is 1 less bead in the bag. So the number of beads in the bag is n minus 1. That's my denominator. And there's 1 less blue. So it's n minus 6 minus 1. So that's n minus 7. So the probability of blue followed by blue is just those 2 probabilities multiplied together. So it's n minus 6 over n. And that's multiplied by n minus 7 over n minus 1. And that becomes n minus 6 multiplied by n minus 7 over n minus 1. So I have those 2 sets of probabilities, those 2 cases, and when I add them together, I will get the answer of 9 over 17. So now I can form my equation. So down here I'm going to put 30 over n minus 1 plus n minus 6 multiplied by n minus 7 over n minus 1, and that equals to 9 over 17. It looks pretty hideous. It's obviously an algebraic fraction, but we should be able to work our way through this and get to a sensible solution. The denominators are the same on the left-hand side, so that's nice. That means that gives me 30 plus n minus 6 over n minus 7 all over n minus 1 equals 9 over 17. Let's expand and tidy up the top there on the left-hand side. So we've got 30 plus n squared minus 6n minus 7n. That makes minus 13n, and minus 6 times minus 7 is plus 42. All of that over n minus 1 equals 9 over 17. And then I'm going to multiply by both denominators, so to get rid of the fraction, so multiply both sides by 17, both sides by n minus 1. So basically the 17 comes up here and the n minus 1 comes up here. So I have 17 multiplied by the whole of 30 plus n squared minus 13n plus 42 equals 9 n minus 1. So now I don't have my fraction. Let's tidy up the left-hand side a little bit. I got 17 multiplied by, inside the bracket, n squared, minus 13n. 30 plus 42 is plus 72. And that equals 9n squared minus 9n. I might as well expand that while I'm going. Left-hand side now, let's get rid of that 17 by multiplying it through. 17n squared minus 17 times 13, that's pretty horrible. That's going to be 221, it's a negative. 17 times 72 is even worse. That's going to be 1,224. Make sure you use your calculator to do these. 9n squared minus 9n there. Now, let's move everything to the left-hand side, keeping my squared term positive. So I'm subtracting 9n squared from both sides. That gives me 8n squared. Add 9n to both sides, gives me minus 212n. And I like to have my 1,224 equals to 0. I don't know what the largest common factor is for 8, 212, and 1224, but I know they're all even, so let's just divide by 2. That gives me 4n squared minus 106n plus 612. Oh, they're all even, so I'll just do the same again. 2n squared minus 53n plus 306 equals 0. Now, you might not be able to spot how to factorize that. I'm not sure I could spot how to factorize that. It does actually work out to be 2n minus 17 multiplied by n minus 18 equals 0. I wouldn't stress myself too much with that in the exam. If you can't spot it pretty quickly, use the quadratic formula. With the quadratic formula then, remember it has to be in the form of an squared plus bn plus c. So here I have a equal to 2, b equal to minus 53, and c is equal to 306. So putting it into the quadratic formula, n this time is going to be equal to is equal to minus b, so minus 53, plus or minus the root of minus 53 squared, and make sure you put the minus 53 in brackets, minus 4 multiplied by a, which is 2, times c, which is 306, all over 2 times 2. So whichever way you do it, you will come up with a solution whereby that n is either equal to 17 over 2 or 18. And clearly, because we are dealing with the n being the number of beads, it cannot be 17 over 2. You cannot have a fractional number of beads. So n must equal 18. If you put the two solutions down there, then you will lose the answer mark. You only get 5 out of the 6 available marks. So with this question, I say these questions are not all the same, but I think it's nice to start off with the tree diagram, but don't complete the entire tree diagram. Just look at which of the roots, which of the combinations you want for your answer. If, for example, the question had asked something like at least one red, then you would have had this journey, and this journey, in which case I would only have worked out blue, and done 1 minus that. So look out for that. That can happen in some questions. Rather than working out 3 of 4, work out the other one, and then do 1 minus that. You might spot that in one of the questions, so be careful when you're approaching these probability questions at the back of the exam paper.